it's time to move on, which means we're going to start talking about what it means to pair or match. First thing you need to know is that this is a technique. It's not a statistic. It's a procedure. All right. And more specifically, it is whoops, I didn't want that to pop up yet. It is a procedure that we use to see whether or not, it is a procedure that we use to make sure that the extraneous variable will not become a confound in our study. All right, so extraneous variables and confounds were explained very early on in the semester. And it really would be a good idea to go back and review everything that we talked about with extraneous variables and confounds. I am going to give you a little bit of a review now, but if you want my advice, I would go back and make sure that I relearn all the things that I told you about extraneous variables and confounds. Okay, so if we use pairing or matching, we're using a technique to prevent the extraneous variable from becoming a confound. An extraneous variable is any variable that is present in your experiment or study, but it's present, and this variable could potentially have an effect on your dependent variable. So an extraneous variable cannot be your independent variable or your dependent variable. It's something else, some other variable. All right, now when we do an experiment, we're trying to isolate the effect that the IV has on the DV. In other words, we want to make sure that if the DV, the dependent variable, is different for the different levels of the independent variable, we want to make sure that that is true, and there's nothing else about your different levels that could be producing a change in the DV. All right, we want to isolate the effect to the independent variable. Oops. All right, so what I'm going to do now is I'm going to go through the procedures of pairing and matching, like that technique. And I'll also go through an example, and that will, I think, lift the fog. All right, you'll finally be able to see through the mist, and this will make better sense to you. Okay, so the very first thing you need to do in this procedure is you've got to identify what is the EV that you want to control for. What is the EV, the extraneous variable, that you want to make sure does not become a confound? Once you've identified the extraneous variable, then you have to measure it in each and every one of your participants. After you've measured the EV in each person, then what you do is you match them up. Match or pair, okay? But they're matched or paired because they have similar values of the EV. So let's just pretend that your EV is age. Now remember, that means age is not the dependent variable and it's not the independent variable. So you've got an extraneous variable age. You wouldn't match a 12-year-old participant to a 90-year-old participant because they do not score similarly on your EV. But you might match a 12-year-old and a 13-year-old because they are very similar. All right, so that's what you need to do here. They have to have similar values. Then what you're going to do is you're going to randomly assign one participant to one group, and the other participant goes in the other group. There's only two groups, remember, because this is a t-test, T for 2. So you can't use pairing or matching if you have a single sample t-test because there's only one group that you're working with from the beginning, right? So this technique can't be used for them. It can be used only when you have two groups where you can actually pair people up and split them. Okay, so this pairing and splitting technique ensures that the extraneous variable will be approximately the same in each group. All right. And that has to be true if you have paired them on similar values. So if you have a 12 and a 13-year-old, one goes to one group, the other goes to the next group. And you keep doing that. So now you pair a 60 with a 58-year-old, one goes to one group, one goes to the other group. You're making sure that the two groups at the very end will be approximately equal in terms of the, mean age for each group, right? The ages are going to be approximately the same. Now, don't worry, I'm going to go through that example and it will be clearer. So once we know that the extraneous variable is approximately the same for each group, it can't become a confound. It's impossible, because in order to be a confound, the extraneous variable must be systematically different between the two groups, right? Between the different levels of the IV. And we've just said that they're going to be the same. So there's no way, again, this EV can be a confound because it will not be different for your two groups. You remember this little mnemonic I gave you? Confound equals dumbfound. Do you remember why? Let's say that you didn't pair and split. Let's just pretend. And you found out that the average age for group 1 was higher than the average age for group 2. Now you've got an alternative explanation for why the dependent variable might have been different. Maybe it's the independent variable, but maybe it's because age was different between your two groups. So you see now that you have two explanations for why the dependent variable was different for group 1 and group 2. Aren't you dumbfounded now? You don't know which one was responsible for the change in the DV. Or maybe it's a combination of both. You're dumbfounded. And that's because you've got a confound. Confound rhymes with dumbfound.